Okay, this is just a quick addition of an explanation, okay, from lecture 9 at approximately the 10.5 minute mark. We were discussing the limit of x squared over x squared plus 4 as x goes to plus or minus infinity equaled 1. And during the discussion today, I was asked to show a little bit more detail of how I came up with this. I came up with m being the square root of 4 over epsilon. In the video, at first, I accidentally wrote 4 over epsilon, but then if you continue watching, you'll see that I realized the mistake, and I came back just a short time later and I corrected it and put the square root on there. Okay, so I want to show you where I got this number from. All right, and so let's do that. So what I did was this. I wrote down x squared over x squared plus 4 minus 1 inside of absolute values. And what I want is I want that to be less than epsilon. That's what I want. Okay? And here's a few steps of simplifying that I did. I said, okay, now that gray stuff there is equal to this. So if I make that less than epsilon, if I make this less than epsilon, then this will be less than epsilon because they are equal to each other. Okay, so one way that I can make this be less than epsilon is by making this be less than epsilon. Okay? And I forgot, what did I do? Oh, hang on, I'm going to have to go back. Dang it. Screwed up. Now, this stuff here in gray is equal to this. I'm just going to try to simplify a bit. Okay? I want this to be less than epsilon. But that equals this. So if I can make this be less than epsilon, just a second here. If I can make this be less than epsilon, then that will automatically make this be less than epsilon, which is what I want, because those two things are equal. Okay? And I'm going to just keep doing the same type of a thing until I get something simple. Okay? So this stuff here in gray is equal to this. Okay, so once again, I want this to be less than epsilon. I can accomplish that by making this thing down here less than epsilon. Because the thing that I am concerned about up here, this thing, whoops, sorry. This thing here, let's number these. Let's number that as 1. Let's number this as 2. And let's number this as 3. Okay, so 1 I want that to be less than epsilon. But 1 equals 2, and 2 equals 3. So if I can make 3 less than epsilon, then that will make 1 be less than epsilon. Okay? All right, going to keep going, doing the same sort of thing. Three is equal to this. Let's call that 4. Okay, now same idea. I want 1 to be less than epsilon, but 1 equals 2, and 2 equals 3, and 3 equals 4. So if I can make 4 be less than epsilon, then I will get 1 is less than epsilon. All right. I'm going to do one more step. And I would like for the bottom of the fraction to only have a variable in it, no adding on constants. I don't like that plus 4 there, and because it's going to get in the way. So here's what I'm going to do. I'm going to write, let's call this one 5. Let's write 4, whoops, wrong color. Four over x squared. Now, these two things are not equal, but that's okay. They actually don't need to be equal. Here's what's important. Line number 4 is less than line number 5. Because why? Line 4 has a bigger denominator, which means it is a smaller fraction. Line 5 has a smaller denominator, which means it's a bigger fraction. So if I can make line 5 less than epsilon, then that means line 1 will be less than epsilon. Okay, so here's another way of thinking about it. I want line 1 to be less than epsilon. And here's what I've done. I've shown that line 1 equals line 2, which equals line 3, which equals line 4, which is less than line 5. So if I can make line 5 less than epsilon, then that means line number 1 will be less than epsilon. Okay? So my original goal is to make line 1 be less than epsilon, and what I have done is I have been able to replace that with an alternate goal, which is to make line 5 less than epsilon, and then that will automatically make line 1 be less than epsilon. Now, I guess the other question is why? Why have I done it that way? And the answer is, well, just look. Isn't this look a lot simpler to work with than this? That's the reason why I've done that transition all the way from line 1 to line 5, because line 5 is so much simpler to work with. Okay, so let's make line 5 be less than epsilon. I want 4 over x squared to be less than epsilon, which means 4 to be less than x squared epsilon, which means 4 over epsilon to be less than x squared, which means the square root of 4 over epsilon to be less than x. And that is our magic number. And now I can say, if x is greater than the square root of 4 over epsilon, then the distance between f of x and 1 equals, and I'm just basically going to write down what I did in my scratch work. Which equals this. Which equals this. Which is less than this. Which will be less than epsilon. And now I have this is less than epsilon, which is what I was trying for. Okay? So that's where I got that number square root of 4 over epsilon from. Now that would not have worked if this was a minus, because if that was a minus, then that would have made that less than face the other direction, and that wouldn't have worked. But that's why I didn't write it as a minus. I wrote it as a plus, so that would work this way. Okay, what would you do if it were a minus? Well, the answer to that is it would be much, much harder, and maybe even we would not be able to figure out a way to do it, possibly. Okay, probably we could figure it out, but I don't think that would be the level of problem that is appropriate for Calculus 1. Okay, so I hope that helps. If you weren't even asking that question in the first place of where did I get the square root of 4 over epsilon, then you don't even need to worry about this. But if you were wondering where I got it from, that's where I got it from.